So, good evening. This will be our kind of a conclusion video to my assessment of the DCC system for my future layout of what I think of what I need to do. We want to show you a couple short videos for the 103, which has now a Lokpilot 4 installed in it, and I will show you the motors in one of these two here and the issues I'm having with the 221 and the cream turquoise color. This one here has a number written on the inside, 27, so I guess they came from a bigger layout when I bought them off eBay, and the owner, one of the previous owners of this engine, may have changed the gear ratio, which I still need to verify on this, because that was a common thing we did back in the days to run the engines on higher voltages on just DC. You would simply change the gear ratio with the different gears Fleischmann has, and this way you can slow it down. And both of these have the newer 58 motors, which I believe Fleischmann changed to in the 1970s to reduce the material used in these motors. They narrowed the magnets, and the magnets probably became stronger. I don't think they are rare earth metals, but as you will see here in a few seconds, is on how they run, especially at the slow speed. And the newer 58 motors, estimating the usage by Fleischmann from 1973 on upwards, I don't know to what time, because I don't really have any newer engines than probably the late 80s or early 90s at the very most here at the moment, until I get some in. And that becomes more tricky to actually set up the Lokpilot compared to the original motor and the 58 motor, as we saw with the blue E10 and the red V200, which we converted, and they're running really great. Where these ones here have to be the CV parameters, there's some tinkering around we have to do. I will not do this. I will just show you on how they work with very minor adjustments, like changing one or two of the CV parameters, primarily the voltage on it, but that's about as much as I've changed, and running the auto tune part of the Lokpilot 4, where it measures itself or measures the motor actually out. And I will also demonstrate on how much current these two light bulbs for the top light actually here will consume, which is right around 100 milliamps. So which is mind-boggling. So just that for those folks who haven't seen this, who have used only LED lighting, of what it is like to work with incandescent light bulbs in these DCC systems when you have limited voltage. So let me get started with this. After these three videos we're going to have, which I'm probably going to post in as short videos too, just these locomotives running on DCC++ with JMI, the one I have set up, slow versus fast, and then the maximum speeds on both of them. Then I will come back, and we may want to sit down and talk a little bit more, and I would like to share with you my thoughts and what my ideas are of what I think about this whole thing. So now we're at the segment where I would like to show you the motor changes they made. And the most visible one to the left here, these parts are the original 58 motor as they came out of the red little V60 with the anchor plates and the 3 parts which go with it. And this is the one here for the newer V221010. And this is the same motor I have in the E103 we will see here. This is basically the same part. This remained the same. This here was changed. This one here can now accommodate the newer type motor shields, which the other one cannot. That is that smaller one, this one here. This will fit in here, or you can use the big one, the old style on this one. So this will do both motor styles, as you can see, in the same frame. But the big change came with the magnets. You can see on how much thinner they are, and they have a, let me see if I can get the light better over here for us. Yeah, here we can see this now. They have a recess in it. The magnet feels differently, and it has a different weight, and this was the original magnet. So the Lokpilot 4 can handle the old style motors better, whether it is the 58 or the predecessor of this, versus this here, what I have in the 103 and then the 221 here. The anchor here has about 13.5 ohms, and the old ones had 14.5 to 15 ohms when you measure from pole to pole between each one of them. So reduced resistance and a changed magnet. I do not know if the magnet is stronger than the old one. I doubt it. But this is basically what they did, and this makes the setup of the Lokpilot here, which I have installed here and this here. I don't want to break my wires, but you can see it. We had to put it in here. I didn't want to drill an extra hole in it. In these old, in these 70s on engines, there is not an awful lot of room for these type of modifications in there. And we will see then now in the next segment on how they actually run and where the issue is. And on this unit here, I believe, on top of everything else, is that I believe that this has a different gear ratio. This here is a larger gear than what they normally put in here, this one. And this may have been a special modified version of this to make it run slower to begin with. As we can see, is we have a number in here which is 21, which was obviously written in a similar color, but the other 221 I have in the other color scheme, but the same setup here, runs faster. That will be the next segment, where I'm going to show you both the 221 here and the 103 with this motor. So here we go with the 221, and I'm going to go straight to 100%, and then you will see what the maximum speed is. And then we're going to reverse the direction. And you can see on how she stutters when she comes to a stop. And this is with the shunt. We go to 50% shunting. Now we can go slow. And this is the changed gear ratio which I showed you with that larger gear in there. Normally that gear is smaller, so she will come up to a higher speed. This is now shunting at about 10% speed. You can't really tell the difference in this low speed. Now we're shunting. She actually runs pretty good. That is, but it was very difficult to set her up to run that smooth. And now I'm gonna put the 103 on, and then we will see how that goes. Okay, so the first thing I'm gonna do is I'm gonna turn on the top light and see if we can see that. Let me take the camera off here. Let me see how I can do this so we can actually see it. Yeah. Yes. I got the light here on F10. And then we should be able to zoom into the meter. I gotta hold this with the left one. So you can see we're drawing 50 milliamps without the light. And if I turn it on, we're drawing 140. So this light here, just the two top light bulbs in here, draw 100 milliamps. And that's what I was talking about on those old Fleischmann engines. That's what they did. Now we go straight to 100. Are we going the right direction? This is what 100 looks here. And we're going to shunt it. It's not very visible. Let me go in the other direction. And you can see there's a slight stutter in there. And that is what we don't have with the older motors. But otherwise they run very quietly and very nicely. Let me see if we can shunt her. Not very much. Let me go to 50. And now we're at 50. Let me bring her down to about 10%. And here you can see this. This is what I was talking about. And that is the parameters in the Lokpilot 4 associated with motor control. And when we shunt it, it is even a little bit more. I'm going to turn off the top light. And you can see it really doesn't improve much. And this is all cleaned up. And this is two parts to this. One part is the worn out wheels, as I will describe later, and the axles, which I have to replace. This is a high mileage engine, and that's basically what this looks like. So we can turn our light back on. And I'm going back up to 50%. Let's see if we take a. This is out of shunt, so without shunt, 50% speed. And back to 100. Shunting. I think shunting off. I guess this way you have an idea. Otherwise she performs pretty well. So this is some parameters and new wheels we have to fix on her. But the overall current is 350 milliamps at this speed and 100 milliamps out of this is the light. We're about at 250, 260. I'm not going to show you this, I'm just reading this off, and this is why I got the lab power supply here. And now we're going to go on to the next segment. So now we have looked at this, and you probably have seen something similar to it. That is normal, since both of these locomotives are not fully, fine-tuned yet. I will do this at a later point when I get building my big layout, when that is going to happen here, hopefully within a year or two. I've written all the things down. Of course, I have everything documented now, so I can just watch my own videos and, look at the issues I had and listen to myself. Then I will remember what I had there. Now, first of all, I would like to thank all of our new subscribers who have come in and subscribed to our channel, or my channel. And you probably have seen this is a fairly simple channel here. We are not doing anything extraordinary. There's nothing there yet on a large, grand scale at the moment. This was just the introduction for me, and hopefully you, to get into the DCC system. Now, I have elaborated about the DCC++ software, which is running, in my case, on the Arduino Uno. That is the slightly older version, not the most current one, with the slightly older version of JMI at the time we're making this video. And you can see that that works actually quite well. So all that took was basically a 12-volt power supply with 2 amps of Amazon. And I'm running, as you saw in the video, this of my lab power supply, my HP, my big one, which I usually have in my laboratory, in my business, in my office. And I brought it over here because it has the digital readout for the current, which makes current measurements easier when you're running this, and you can immediately see when you turn something on or off and how much current this is going to consume. That was really the only reason why I dragged this thing down here, was because it has the built-in voltmeter and amp meter, which makes it a lot easier, to do assessments and just take a peek at it and see, oh, it draws 200 milliamps, 300 milliamps. Otherwise, I have been running this on that little power supply I bought there. It was like $10 or $12 with the shipping. That was when I had Amazon Prime 4 years ago. Now it was in 2020, 4 years ago. And so we probably paid about $12 with the free shipping because of Prime. And I paid $14 to this company, which is on eBay. It's a Chinese company. It's DIY, do-it-yourself, basically. And they list these cloned Arduino Uno boards, and they had the motor shield, the correct one I needed. The L2, is it now a 289 or 98? I can't remember that. Well, anyway, it has the that chip on it, which is the horizontal version. That's why it got HN on it. It was originally made by ST Micro Devices or Micro Electronics in Switzerland, and I guess they outsourced this. It is normally used in for step motor controls, for stepper motors, and they can handle up to 4 amps for regular step motor to drive them. And they have actually a driver chip for that as well, a complementary set for it. So the Arduino people, fan community, has basically used that particular chip to drive all sorts of motors and stuff like this, which it is quite suitable of doing. It's a pretty neat control. But like I said, as the current is very limited, as higher your current draw is, as lower I would go with the input voltage. As higher the input voltage also goes on those, as more of a voltage drop across the input versus the output you're going to have on this. ST Micro, in their data sheet for this device, specified 2 volts to up to 5 volts. And it can actually take 50 volts altogether, but it is not recommended. And with a heatsink a pulsed current, not a continuous current, but a pulsed current of up to 4 amps. But so for continuous current, you probably 1.5 amps, you're going to be on the safe side. With the way this is at 12 volts, you should be fine. You probably could go to 14 volts if you keep the current under 1.2 amps, and it should do you just fine on this. That system, so we have $12 into the power supply, $14 with the shipping. That was in 2020, is probably more now. So for $26, we got basically the hardware required, and the software in this instance is free. And I had to supply my own USB cable, which I had, which is the Type A and the Type B connector on each end. And that worked just fine. And then you're basically up and running. You just need some tracks, an engine with a DCC decoder in it. I keep saying encoder, it's a decoder. And so you can build basically a model railroad for probably less than $50 if you get a locomotive which has already a encoder or decoder built in. I gotta remind myself to call it decoder, like the Lokpilot, and you're basically up and running. So if you're on eBay and you get a few tracks together, no matter what manufacturer, you can run this system on, I guess the DCC system will only do DC locomotives with the decoder in it. Then you basically are up and running in a digital format for probably less than $100, plus the locomotive and whatever rolling stock you may wish to purchase. That is a very low entry price into this hobby. And I have to say one thing is, I think 3 days ago, I looked up the manual for the original Fleischmann Twin Command Center. I think that's what they call it. That was their first or second generation DCC controller. And it had the throttles you could hook up to it with the telephone cable. And it had a liquid crystal display, I think a 2-line liquid crystal display, where you can then scroll through with push buttons going up and down and enter key and that sort of stuff through the menu and call up on all the different CV parameters. And that is a totally cumbersome system. That manual itself is 120 pages long because it has like 4 languages in it. But if I would have gotten into DCC with Fleischmann Twin Command Center, with the Fleischmann Twin Command Center in the late 90s or early 2000s, mid 2000s, I probably would have lost interest, because in the newer Lokpilot, just in the Lokpilot 4, you have probably well over 100 CV parameters, which each one has a different function or does something or, regulates something. And you have to go through this. So in the JMI with the spreadsheet format, or even with the different tab groups they have categorized, by the different headings, motor, basic motor, and advanced speed setup and regular speed setup and that sort of stuff, makes it a lot easier to adjust everything and then just do a complete write or complete read. On that Fleischmann thing, you had to go through one CV at a time. So if you wanted to go to CV 125, you had to push this thing or hold it down until it scrolled down, and you had to hit enter, and then you have to either say read, write to see what's in it. And it was a very cumbersome system and very, very difficult to maneuver through on a 2-line LC display. That's what I have to say. Fleischmann had obviously a software, I believe, because the command center, the Twin Command Center, they call that, had a DB9 or DB25 RS-232 serial connection to a PC, basically. And I guess there must have been some software where the programming probably could have been done easier. But if you had only the Twin Command Center with or without booster and the Fleischmann transformer, and these handheld throttles, which look like TV remote controls to a certain extent, hardwired into that. I think you were able to get up to 4 of these handheld units into that. I think that would have turned me off. At that point, I would have stayed with DC, especially with the, advanced DC controller I had with the pulse width modulation, which we're going to build too. I have these circuit boards made up here, and eventually we will feature this here on the channel as well, just to document this. But I would have stayed with DC just for the ease of use and everything, because normally when you new to model railroading, the neat thing is you have 2 wires, you hook them up to your transformers. They're usually color-coded, or with Fleischmann they were Märklin too. Märklin was brown and blue, if I'm not mistaken, for the track, and Fleischmann had 2 yellow wires, because you can go either direction with it, and if you wanted to change it, you just flip the wires around. On the transformers, you didn't need a screwdriver or anything. That was already attached to the one curve usually, or to a straight track, and you plugged it in, you put the track together, you put your engine on it, and you plugged the transformer in, and you were up and running. It didn't nearly take as much sophistication and engineering work to get a engine to running like what it can take with a DCC decoder, depending on the motor and everything else. One thing I wanted to mention is on the E103 here, you saw in the video, is the one part of this came also probably from a larger layout. Some of these locomotives I bought over eBay, like I said, is they have numbers attached to them. So someone had a larger layout, and they were not digitized. None of these ones, except for one ice train I have, has a Lokpilot 3 in it. All of them were DC layouts, but they were numbered. So I guess the owners kept track of them. And these are usually the ones which are in very good condition. They were very well cared for. But on that E103 is that got a lot of mileage on it. As you saw on the video, I pointed to the axles and wheels, and they're pretty much worn out. And unfortunately, Roco does not have them anymore and does not offer them. So I will have to see if I'm going to find a low mileage 103 one day on eBay with a beat up chassis, where I can recycle the wheels and the axles out of it for both the pickup side and the motor side. This way I can get this going. So that is part of the connectivity flickering problems we have on that engine. Is not from the track, but it is actually worn out on the engine itself. The other thing is I wanted to mention really quick within my channel now, is because I get the channel data from YouTube, is that the primary viewer groups by country is about, I would say, 15% in the United States and 10% in Germany. So 25% of the views are in those 2 countries of my channel, and 75% are scattered pretty much all around the globe, from Eastern Europe, Russia, to the Philippines, down to Latin America, and and then the remaining European countries, and then some viewers up in Canada. Hello to Canada. And of course, I'm happy when a subscriber comes in from any country. If you subscribe to it, it's kind of a validation that the time I do put in making these videos is not lost completely. The short videos are usually liked by the younger people. Some of these people then also watch the longer videos, but the young people, this means now the age group from 17, I think they start at 16 to 54, is primarily they're watching the short videos. The remaining from 54 on until you can't watch anymore, basically, or close to that, they're the ones who watch these videos you're watching right now. That's why we're getting less views. But the information, which is hopefully useful, is contained in the long videos. I cannot see on how you could put all of this information about these topics into short videos, because you have about 1 minute. That's how much YouTube gives you to make one, and there is not a lot of information. First of all, I'm not a fast talker. That's why I didn't get into car sales or wash machines or that sort of stuff, selling any of those items. And I didn't get into late night television for your infomercials. But wait, there's more, that kind of stuff. I didn't get into that either, because I'm an engineer. I'm a thoughtful person, I hope. And I'm trying to be meticulous with what I do. And those things, that just doesn't fit. At one point or another, you have to go into theoretical parts of a job or an application, and then you can go into the practical side. There's both sides to it, and you can't really have one without the other, without getting a profound understanding, unless you just want to know one thing on how to basically screw in, do that, and then go on your merry way. The videos I have posted, this is similar to my car channel I have, where I documented the rolling repairs of my 1989 560 SEL Mercedes-Benz with 346,000 miles I have on that car. And on that channel I have, as of today, like 2,500 or close to 2,600 subscribers. And there I did make a lot of tutorials, and these tutorials are very popular. And most people actually on that page, on that website, on that channel, come in through Google search or Yahoo search or Bing search. They're looking for a particular topic, question, or answer to a mostly fuel delivery related problem. And they wind up then at my channel, and then hopefully they get it. From the feedback I have been getting is that most people understand the explanations I give them, and it has helped them in maintaining and getting their car to run if it wasn't running anymore. Anyway, this is something similar I would like to do here. The real part of this whole channel is probably going to start when I'm going to start building my layout, and that is going to be a big layout. So we will have multiple repeaters or boosters, and I will explain in those videos, and when we get there, on how to properly lay out the correct size in DCC or for DCC with the power assessment. Then based on this, what we did here is the initial research. So I have this now documented, and I know what currents I'm up against, and what I can expect there, and what the track has to be able to handle, and on how many feeds and how often we have to repeat the feeds, and how we have to basically split up this entire DCC bus system as a ring circuit, basically, with boosters throughout, in order to supply the correct amount of current into every part of the layout. So this would be the engineering challenge, so to speak, electrical engineering challenge. So we don't have any zagging voltages in some areas. Like, if you go up an incline, you want to have plenty of power available on the track for your engine, so they won't bog down, because the voltages can drop significantly on a large layout if the tracks get very long and you don't have a constant feeding into the track system. I think I had explained that already earlier too. Otherwise, yeah, that was the primary thing. Thanks to JMI and DCC++, that basically sold me on the digital world, or into the digital world of model railroading. And I'm glad I saved myself the early days of DCC, which some of you have lived through, my viewers, and probably can write a book about it, of what you had to endure and the trickiness and the incompleteness of certain systems. And I believe that the downfall of Fleischmann, where they lost or started to lose market share, was because of the twin command center and the way it was structured with this two-line LC display system. Some people who are very adept at electronics and that kind of programming, going through an LC display, and they can memorize all these different CV parameter numbers of what they mean and what they are, they will have probably an easy time. The more average person, which I consider myself one to be, I would have sat there and I can't remember what CV24 does unless I have the booklet out and I have to look it up, and then CV54 and 53, and this is K, and the other one is I slow, I fast, K slow, and voltage, and you name it, and then the whole functions with the F1 key and the F2 key. This gets rather confusing, especially when you have to assign multiple tasks to a particular CV position, like a function key. Is it on? Is it off when you push it? What is it going to control? AUX 1, AUX 2, front light, rear light, whatever you do there. It becomes pretty cumbersome to memorize this. So in a spreadsheet layout, like it is in JMI, it's very user-friendly, much easier to maneuver through. You can set everything up and then just download the whole thing or upload it, however you want to call it, into the engine, and restart the engine, and then you're up and running basically. And then you can send the new instruction or change CV over on the regular run track too, if it needs to be changed while you're running on the track without a acknowledgement or readback possibility. That is something which has made that easy to get into. That's at least my personal opinion. And if a younger person watches this, say like someone was below age 54, and you normally are watching short videos and you actually lasted, now I would say probably 25-30 minutes or so better into this video, my congratulations to you. If you don't have the money or you want to start small, I would go with the Fleischmann layout like it is in the older catalogs, like I showed in the other video. You probably can pick up the track material. Doesn't necessarily have to be Fleischmann track. It could be any other one. It's just an idea on what that layout looks like. And just get the Arduino Uno or Mega now, the newer one with the newer motor shield, and get started. And it gives you a head start. And then when you decide you like it, you haven't spent a lot of money on it, then you can go ahead and expand it, until you're either going to wind up with a big system or however you like to go. That is the fascinating thing about model railroading. I don't think there is no other hobby which can give a person so much individuality and freedom to choose of how you would like to do it. What trains you're going to run, what consists you run, whether that is original, the way the railroad does it, or you put your own thing together, the way you build your buildings, the way you structure your landscape. All of this is up to you. There is no right way and no wrong way of doing any of this in model railroading. And it is only, it is as long as you like what you got, that is all what matters. Other people may like it or they may not like it. That's just the way it goes. I've watched many other videos from other model railroaders. And, some things I think that's a neat idea. I say, okay, that's what he or she did there. That's how they choose to do it, and may not be necessarily something I would like to do. It's the same thing with scale, N scale, TT, O1, HO, or Z scale. If you want to go with that little tiny thing from McLean, then it's all up to you. It's your fantasy, not fantasy world, but it is your kingdom. You choose of what this is going to look like it. And there's no judge in this. So everything I have presented here in my videos, the way I repair it is just the way I do it. There is no set way in doing anything. This is just one way of doing it. And there is, like they say, there's multiple ways to skin a cat too. And that is true with certain repairs. Or some people clean it this way, other people clean it that way. They believe that works better. Some people believe brass is the better track. Some think the silver nickel thing, what we got there, is better. Or, even if you have the old steel tracks, it's all a matter of choice. And it depends on what you like, what do you want? You want the theme of it. There is no right and there is no wrong in this, There might be a better solution, and sometimes I look at videos and say, that is a smart way of doing it. I got to do it, too, that way. That's better than what I'm doing. Since I don't have all the answers, basically, that's what I'm saying. Everything is meant to be suggestive only. You take what you leave, you take what you like and you leave what you don't like. That's as simple as it goes in model railroading. And I will be checking back in with you here on this channel when we're going to build the Dream controller for the AC unit, when we get that completed. And then we're going to build the Dream controller for the DC version with the pulse width modulation. And we're going to hook that up on both of the little tracks with the Fleischmann transformer on the DC as a source, and the McLean transformer as a source for the AC, because they are just basically hooked up in between the track and the transformers. And then I will explain this on how that worked. And if there's any interest in this, I can see if I can get you a circuit board, and then you can get your own parts made up. The boards are probably going to be about $15 or $20 a piece if we have a few of them made up professionally. And, we can put them in an envelope for you. There's like $3 for shipping involved in it. First class, and if you're here in the United States, and then you can build that yourself if you can solder and you know a little bit about parts. And with that, thank you again for subscribing. Thank you again if you hit the like buttons on my videos. It really doesn't do much in terms of YouTube, but it is a recognition for me that people appreciate it, basically, that I've taken my time out here out of my day to share some information with you. And with that, have a great evening.